The first property is basically if you have if you have one log of, let's say, if something, a times b, some base, there's always going to be a base here. This is equal to, we can split this into two logs, log a plus log b, okay? So we can either turn two logs into one, or we can take a log and split it. If you have two numbers here, we can write it as two logs, to something like that. And we can also, the other one is, so this is a multiplication. If you have a division, you can also turn this into two logs. But this time, if we have division, it's going to be a minus here instead of a plus. Okay, multiplication, we can turn that into two logs with a plus. If you have a division or a fraction, that turns into two logs with a minus. And the other one is basically if you have log of some, let's say, a, or x to the power a, we can move this power to the front of the log, so it turns into a multiply log x. Okay, so that's another property of the logs. There are a couple more. Sometimes you may have a log and an exponent. An exponent over the whole log. Before that, let's do another one here. If you have a log and let's say the base here happens to be the same as the number here, this will always be 1. If the base happens to be the same as the number inside the log, the value of that log is 1. And you can tell why, because we said this to this power equals this. So b to the power 1 apparently is equal to b. Okay, so that's another rule. We have one more. So if you have a log to a power, let's say, or a power to a log, let's say you have x to the power log x. Okay, so if you have, that should be equal to, let me just make sure I'm writing the right formula. Just 1 second here, I'm looking for the formula. So we have a few formulas, but we're only going to talk about the important ones, about 5 of them that we need to simplify expressions. And the last one is, what is it? That's right. So let's say you have some base here. Then maybe some number a. Okay, so we have a base. And the whole power is log. That log itself has a base, which happens to be the same as the base here. In this case, if these two bases are equal, are the same, this turns into just to a. Just like here, if you have the same base and the number here, that turns into 1. Okay, for this one, if the base here and the base here are equal, then this simplifies to 1. I mean to a, whatever the number here is. This is a base, okay? It's not the base of a, it's the base of a log, small number here. And that's pretty much, we're gonna work around with these 4 of these 5. This should be enough, I believe. Okay, yeah. Okay, so that's good enough. Now let's do some examples with these properties. So the question may say, or you may have, for example, log, let's say base log base 2 of 8 plus log base 2, let's say, of, let's make these. Okay, so the question may say, turn these into 1 log and simplify. Okay, so we need to turn these 2 into 1 log and simplify. Okay, so according to this rule, so we can put these two together. If we go back, we just need to multiply a and b. Multiply them. So here we're going to multiply 8 and 2. So this turns into a 8 times 2 here, which is basically log of 16 base 2. Okay, so these logs, put them into 1, and then we're going to try to simplify this. 2, what is log base 2 of 16? In other words, 2 to a power is 16. What's that power here?
To the fourth.
The 4th power, that's right. This is what we talked about last time. You saw how to simplify logs. And
Can you say in the other expression, in the other rule or property, that if the base and the login, whatever, the base and the, what is that, the index is the same, then it's supposed to equal 1. So why would it be 8 times 2? Why wouldn't it be 8 times 1?
you can also say that this one is equal to 3, right? 2 to the third is 8. You can also say this is 3, and this is 1. And we get the same answer.
We would.
But the point here is to, basically just to demonstrate how this rule works. It is especially useful sometimes when we can't find this log, we put them together into 1. But this is just a simple example to show you that the rule actually works. Basically, we're trying to prove that it works. Let's see another example where it's useful to use this rule when we don't know a certain number. Or
So the bases have to be the same for this to be true also?
yep, throughout all of these, we have to have the, excuse me, we have to have the same base for all these in order to put them together.
Okay.
If you have something random like this, whatever, something like this, and we want to simplify this or put these two together. So again, take the log, the base should be the same and it stays the same, and just times the 2 together. this turns into two logs 35. You try to find if it's a number like this, 3 to a power is 35. If you can't find it, basically we leave the log like this. So not every log has an answer that's a whole number or something like this. Sometimes we can't find that specific power. Usually it does exist, but it's a decimal number, so we can leave this like this. And if we want the actual answer to this, we can use a calculator. There is a log button in every calculator that we use to simplify or find the value of logs. You can try this if you want. Log base 3 of 35 will be some decimal number. So that's pretty much how that first rule works. It's very simple. It just works straightforward. It helps again sometimes when we need to either split one log or turn two logs into one. So we can go back and forth between that. Now let's look at the second one, second log. Let's see a log of 16 over, let's say, something like this. So we have a fraction inside, so this turns into a log of 16 minus log of 3. Okay, if you have division, it turns into subtraction. Then you try to simplify what you can. Again, log base 2 of 16 is 4. 2 to the power is 3. That's obviously a decimal power. Okay, so I'm just going to leave that like that. Kind of like we did with the radicals. Sometimes not every radical has a value, so if it's something like this, for example, this is a decimal, we'll leave it like this. So in this case, this is equal to 4 minus log base 2 of 3. What else? Let's see if we can do another example. So you may have this, or you may have, let's say, log base 5 of 7, and here 3. The question may say, turn these two logs into 1. Okay, may say turn these two into 1. So what's the resulting log if we put these two together?
7 over 3.
We log of 7 over 3 base 5.
5.
So these are pretty simple to use, pretty straightforward. This one is also important. That's actually more useful than the other ones. So let's say you have log. We have 9 here, and we have, I don't know, 7, for example. We can do this very quickly here without pretty much a calculator, without anything, using the rule number 3 here. So again, this 7, we can drop it. So at this point, it's not easy to find. 9 to the 7 is a very large number. You don't want to evaluate this and then try to find the log. Instead, we're just going to move the 7 to front of the log, so it will be 7 times log 2 to the power, log base 2 of 9. What is this equal to? 7 times log base 2 of 9 is?
81. It's 81.
3.
Is 3.
Oh.
Okay, so
Oh,
that's actually useful, as you can see here. Simply move that here, or sometimes you may need to move it up depending on the question. For some reason, sometimes you need to get rid of this number from here. Let's say you have 2 here and 5. And we can just move this back up here to the power. It would be 2 to the power x of 5. Sometimes, again, we need to, especially when you put two logs together, before we put two logs together like this, if you have any number in front of the log, it needs to be moved inside to the power before we can combine two logs into one. For example, if you want to put these two, okay, we want to combine these two logs into one. We have the same base, that's good. But before we can combine them, before we can multiply 2 and 4, as we did in the rule number 1, we first need to get rid of this. It has to be moved inside. Then we can put the logs together. So this turns into a log base 5, 2 to the third, and the other one already is by top. It doesn't have a number here, so we can say, now we can put these two together. That's log 8 and 5 plus log base 5 of 4. Okay, now that we have the logs by themselves without a number here or here, we can multiply these two as we did in the rule number 1. So it's be log 8 times 4, which is basically a log of 40. I mean 32. Now at this point, sometimes this may end up being a whole number, 5 to the power. It might be, for example, if you end up with 25 here, this will be 2. In this case, there is, I don't think we can find the power here. It's not a whole number, it's going to be a decimal. So the question basically here was to put two logs into one. Once we unsimplify if possible. So we put them into one, can't simplify, so we'll leave them like that. So that's the answer here. Of course, this one here is pretty straightforward as well, pretty simple. What else? And also this one here. So let's say we have this example like that. This will say simplify, not put into one. So if it says put two logs into one, you're going to use this. It says here put these two logs into one, use this. If you just said simplify, you can say 3 here and 1 and add them. Okay, I may ask you to put two logs or more into one, or simply evaluate a log. Let's say evaluate this here, 7. Plus maybe some power here, 3. Minus log . Okay, simplify this whole expression. Now that we know the rules, we can do this pretty quickly without a calculator. So what happens here? First one would be, again,
1.
1 plus. What is this equal
That's
to?
5.
That's right. The base here is the same as the base. This will be equal to 5 minus. And this one. Let me change that a little bit. Let me make it a little convenient. Let's make this a 2 instead. Okay, what would this the value of this log be? Again, that's just like this rule or this one. Okay, so we're going to use rule number 3. So this would be 7. Okay, if you move 7 down. And what else? Log base 2 of 8 is? What is log base 2 of 8?
4. Will be 4.
No. log base 2 of 8. 2 to the power x is 8. What is x?
3.
3. And now we can do 6 minus 21, and this will be, of course, 15, right? Negative. Okay, and that's pretty much how the logs work, or the properties, rather. Simplify what seems to be like maybe complex expressions with logs, and simplify them easily when we know the rules. These are the main 5 rules that we're going to be using pretty much. Let's see. Let's look at some other examples. Probably see if we can do some longer ones. Let's say log base. By the way, every log has a base here, as we saw before. If you don't see a base, in a log, the base is by default 10. Okay, so the base by default is 10. If you don't see it, by default in the calculators, your base or the base is 10. Okay, so unless you change it, unless you want to use a different base. But if you try to find the log in the calculator, again, if you press the log button, that's by default base 10. It may say it or may not say it, but whatever it is, it's going to be 10. So if the base is different than 10, so you need to know that the calculator only gives you base 10, and there's also another base called n. I believe it's called n, Neperian number, but that's something different that we're not going to need in this class. Base n, I believe, which is number. Okay, so again, if you don't see the base, it's by default 10. So I'm not going to write the base here. I'm just going to say 2x minus log of 3 log, let's see, xy actually, let me make it like this. Okay, so let's try to put these 3 logs into 1 log and simplify. It's a typical question. Write as 1 log. Simplify if possible. All right, so we have a long expression here. We're going to start with these 2 first, put them into 1. Once we get 1 log from here, we're going to see how to combine it with this one. All right, for these 2, how do you turn these into 1 log?
You divide.
And before dividing, what do?
Get rid of the 3.
Yeah. That's right. So we have that 3 there. We're going to move this up. It's going to be a log. What is the base of these logs, by the way?
10.
That's right. We don't see a base here, so that's 10. So before we combine them, let's move the 3 up to the power. make sure you use parentheses here because it's going to be power to whatever is inside, not just one of them. It's going to be on both. Plus log x y of 2. Okay, so again, rule number two actually. If you have a minus, you can put the logs together by dividing the number inside the log. That would be 2x over x plus xy. And we bring this log down. Okay, we're down to 2 logs. Now, how do we put these two together?
Supposed to multiply.
That's right. I'm just going to multiply the inside, so it's going to be a log of going to be multiplied, so this times the other log. It's all inside one log. Okay, we said simplify if possible. Can we simplify?
I mean, you can multiply the insides of the logs. I see what you did.
Let's
Can't you
simplify first. What do you think cancels if we would simplify?
I would cancel the 2's out.
That's right, the 2 first. What else?
Then I would
X and Y.
cancel the x and the y.
That's right. So we can either cancel x here and x here, or we can cancel xy and xy, and the power becomes what? If we cancel one of them, the power becomes
2.
That's right. So basically we have 3 of these, but if we cancel one of them, this will be x over just xy to the power 2. Can we still simplify?
Why it's 2?
Mm-hmm.
Why it's 2?
You can get rid of one of the x's.
Because if you have, let's say, a over a to the power 3, right? We cancel one of the a's, be a 2 here.
Oh, okay, I got it.
And we can simplify a lot more here.
Cancel one of the x's.
That's
Well,
right.
the 2 x's together.
So we have x1 here. This x has power 2, so we cancel one of them. We can end up with log. So just x and y2. Okay, so the y stays with power 2, but the x here, x has power 2, but one of the x's cancels against 1, so we have just x to the first left. The power 2 now is only for the y. And as you can see, we went from a bunch of logs into one pretty simple log.
Does it need to be in parentheses?
If you have a lot of stuff, I would suggest you put that in parentheses. Yeah. It's not necessary, but I believe makes it clear to read the log and what's inside of it. There is another example that I wanted to show you here. Can't find it. Well, the book doesn't have it. The book only has simple logs with, well, let's see, might find it here. All right, so one more example. But actually, let me know what it is. Any questions about any of these problems so far, everybody?
No.
Those are pretty simple to use. Just remember the rules, okay? Remember all of them. And using them is not that bad.
The one question that I do have is, when do we know if they want the actual answer versus just you know, all this other stuff. Because like some of them we were giving numbers like 15 and whatever. And then even when we had the numbers, we didn't actually give an answer. We just gave like whatever log something something.
Well, if we know the numbers, so here, for example, the last one we have x and y. We don't know what x and y are, so we'll leave that like that. If you have numbers, we try to simplify them. If we can't find that log, as we saw in the previous examples, so we leave the log. We leave it like that. We don't want to write it as a decimal. But
Okay.
the question usually would tell you exactly what to do. It would say, or write as one log, or simplify, or whatever the case might be.
Okay.
Mhm.
Professor, can you do one
Yeah, I'm looking for another
like the
one.
last one you just did there without the X and Y and it has actual numbers? So
That's what
I'm
I'm
coming
looking for.
across it.
That's what I'm looking for right now. There's a couple of good examples
Okay.
that doesn't end in logs. They end in specific numbers. I'm just too lazy to make one up. I want to find it. So I'm sure I have a couple here somewhere. Usually I make this on the fly, but I'm feeling a little tired today.
Teacher, is the exam on Thursday or Tuesday?
Thursday.
Is this, please tell me this is not going to be on the exam.
Hmm?
I don't think we had enough exposure. Wait.
What is it?
I said, please tell me this is not going to be on the exam. I don't know if we had enough exposure.
Most likely won't be, but what we did last time, you'll see a couple of questions like that. But we'll see. We'll see. Haven't designed the exam yet, but we'll see. Okay, so this is here. We have a good example. There it is. All right. Let's say base 3 of 27 minus log base 3 of 5. Well, we can even make this a little more interesting here. Let's turn this into, make a 3 here and a 3 here. All right, so we have a bunch of logs. Again, without a calculator, we're going to see how to simplify this, and you'll see that the answer of this, you may end up with being a log of something that we can't find without a calculator, or if we're lucky, it could be just a number, let's say 5 or 6, whatever, just one number out of all this stuff. So we're going to try to simplify all this without, like I said, without a calculator, but we do know some rules, so we're going to apply all these rules and simplify. Basically, we're going to basically do this again. Since here we don't know the numbers, that's why it stayed like this. We don't know what x and y are, but here we have some numbers. Hopefully we can simplify the end result here and see if we can end up with some whole number from some perfect log. All right, so first let's put these two together. As you can see, you can't find any of these individually. 3 to a power is 15, 3 to a power is 5. Maybe this one can be found easily, but let's say put into one log. So write as one log. What's the first thing we do here?
Move the 3.
Move the 3 up, so it turns into a log. 3, 27, okay. 3 to the third becomes 27 minus log. Gotta make sure the bases are the same before you can combine logs. There's 3 here. We have 3. We have 3 as a base for all of them. That's good. We can put them together. Let's put these two together here. What do you get? If we put these two together.
27 over 5.
That's right. 27 over 5. As you can see, nothing can be simplified here so far until we put everything into one log. And now these become, what do we do with these two?
You're going to multiply it.
That's right. So 27 over 5 times 15.
Over 1.
That's right. Let's okay, put into one log, we did, and simplify it. Let's try to simplify here. So how do you simplify this expression here? First,
I would
reduce by
cancel.
5 will be 3. What's 27 times 3? 27 times 3 is 80.
81.
81.
Stay tuned.
81, that's right. So far, that's pretty good. We have one log. So we can simplify this ourselves. What is this equal to? Log base 3 of 81 is?
It's 9.
Not 9.
No.
27.
3 to a power is 81. What's that power?
27.
It's 4.
4. That's right.
Yeah.
Very good. As you can see, this whole thing is basically just 4. Okay, so that's again the usefulness or the convenience of these rules. We can work around expressions and simplify them, reduce them, even when you don't have calculators or computers to find the values. Okay, again, this is nothing bad here, pretty simple, just combine adding or subtracting numbers basically, and at the end, you simplify your log if possible. If not, like here, you leave it like that. And that's pretty much it for the properties of logarithms. These are again the rules. It's pretty much all of them here. Everything else, it will be derived from these. If you see any other formula, it will most likely be a derivative of one of these here. So, but these are the main ones. Okay, everybody, any questions about any of these? Any questions, everybody, from these problems?
No, I think for me anyway, I sometimes I forget how to read the log to
Mhm.
remember that it's 3 to the 4th power equals 81.
Mhm.
So just
So
yeah, that's the only thing. I have to remember how to read it. Once I remember how to read it, then
just turn it into a power. Just turn it into a power. You can either write it down or just in your head, you turn it into a power. This to this power equals this. Okay, the number here to this power equals this. You can figure out any number that's missing here if the logs are with convenient numbers. So this to this power is this. You don't have to read the log itself, but as we said before, when we deal with logs, we turn them into powers. And they make more sense when we turn them into powers.
Mhm.
Okay, everybody, let me give you a few problems to do on your own. Okay, and all right, so let's write some problems here. So simplify or put it right as one log or whatever. Let's say simplify. So let's say log. Of course, something like this. And write as one log and simplify.
What's the third one? Log 10?
Yep. Okay, write as one log and simplify if possible. Log AB minus C log okay, and simplify if possible. There's this one and another one. Should be it, I believe. Yeah, that's good enough. Okay, so these just simplify, find the value if possible. Here, again, write as one log, this whole thing. And of course, simplify when possible. All right, take some time to do this and we'll check with you. Okay, everybody, let's go over these problems here. What is this equal to?
Log 75 base 5.
6.
That's 6. If you move 3, then you have log of 25 base 5 is 2. That'll be 6. And this one, of course, is? This one?
7.
7. Yeah,
7.
1 and 4. You have to be the same. And what's the base of this log, by the way?
That's
1.
10 plus 1.
The base is invisible 10. And we
Wait a minute. Can you go back to the first one?
Yeah.
What 25 to the third? It's not 25 to the third?
It is.
Or it's 25 times 3?
To the third, but we got to move this one to the front here. And then evaluate the log. 3 more here. Okay, so
Oh, okay,
this
that's
will
what
be.
it is. Okay.
So this will be, again, invisible base. It's 1. If the number here and here, the numbers are the same, it's 1. This invisible index, not index, but base here, which is 10. Now we're going to put these two together. So first, we're going to divide these. It's going to be a log AB. But actually, we need to move this up first. It's going to be log AB minus log 1 over D to the power C plus log AB squared. By the way, if you want to start from here first, that's fine. If we multiply these two, I mean, if we could put these two together, what do you get? So to put them together means we multiply this by this. If you multiply this by this, what is it equal to?
Log AB to the third power.
Mhm.
That's right. We're just going to add the powers 1 and 2. Okay, and you have 1 left here. You can do it in any way, just like regular numbers. You can move them around with the commutative property. So we have 2 logs. Now we can, what do we do with these 2 logs now? We have a minus, so we'll
We're supposed to divide it, but
divide. Okay, so it means this over 3, divide.
how do you?
You can divide, or you can flip it. You can divide, so that's 1 over d, 1 over d c to the power. So when you divide, you can flip this one, right? Just like we do with fractions. You can turn this into a multiplication, but we flip the second. You change flip, so it's going to be ab to the third multiply d over 1 to 2c. And this denominator over 1 becomes irrelevant. We can get rid of it. It just becomes this. Okay, again, division is basically multiplication if you flip this second one. And if you flip it, the 1 becomes irrelevant. So that's basically what you get at the end, and you can't simplify this anymore.
Couldn't you have left the c log 1 over d, well, negative c log 1 over d, as that being that you're not really able to do anything more with it in terms of the rest of the logs?
So the question was to write as 1 log and simplify if possible. So this is what we wanted. So we wanted 1 log, there we have it, and we simplified as much as possible. So that stays like this. The inside operations are just like any other operation we do. Only new thing here is to put the logs together. So this would be good enough.
And the subtraction sign is not putting it together?
Subtraction sign, that's what gave us division here. That's a real number.
No, I get that part. What I'm simply saying is that the c log 1 over d, right?
Mhm.
Because you still have a multiplication sign in between both of them and you can't do anything with it. So technically it's not consolidated.
It is consolidated into 1 log. That's what the question was, right, as 1 log. The main thing here is just to put all the stuff together into 1 log. Instead of 3 logs, 1, 2, 3, we have 1. That's the purpose of this. Just like before, we don't know the numbers. If we knew what the A and B and D were, we would plug them and simplify. But in this case, that's it. That's the whole thing. If we're lucky enough, like here, you may end up with 4 if we know the numbers. And let's see if we can get that from this example. So if you put this into 1 log, we're going to have a log. We're going to times these and divide by 16. Okay, so it's going to be 8 times 15.
400.
400 minus log 16 of 5. So 400, or you can actually, if you don't want to multiply it yet, we can simplify at the end after we combine everything together. So we have 16, we have 5. Maybe now instead of, it's probably better now to simplify so we don't run into that large number 400, but it's fine if you multiply here and then divide. So what do you get here? You can see here that we can just cancel 8 and 8. We can cancel 8 and 8 here, so we can have 2.
2, which leaves 25.
That's right, 50 by 2 is 25. So it's easier to simplify now. And this will be
2.
2. Okay, so we could have actual numbers, or we could have variables. Either way, just put them together, simplify. And that's pretty much the logs and the properties and their applications. You'll see some of this stuff in the homework. Maybe not. You'll see one of these in the exam, maybe one of these like that. Very simple. Add, multiply or divide and simplify. No big deal. Okay. It may look intimidating or complex, but as you can see, very simple to work with when you know the rules. Any questions?
Can you go back down